Okay, so we're going to have a look at some IB Maths high-level vector past paper questions. These can be a little bit tricky, so let's see how we get on with them. The first question gives us some points as the vertices of a tetrahedron. Find the vectors AB and AC. That's the first thing that we need to do. We're then going to use that information to help us find the Cartesian equation of the plane, and then we're going to find the distance from a point onto that plane. Okay, so the first thing we need to do is find the vectors AB and AC. Okay, to do that, all we need to do is work out the point B, take away the point A, and here's the point C, take away the point A. Okay, if we do that, we end up with minus 4, minus 1, 3, 4, minus 3, 1. Okay, and we can label these as U1, U2, U3, V1, V2, and V3. And this will help us when we come on to the Cartesian equation for part B. Okay, well, part B basically asks us to find this Cartesian equation of the plane. Well, if we've already got the vectors AB and AC, well, these enclose the plane. So basically, if we find the cross product of these two vectors, that will help us work out what the equation of the plane actually is. Now, to work out the cross product, we need to use this formula here, U2, V3, take away U3, V2. That gives us the I component. Then U3, V1, take away U1, V3 gives me the J component, and so on. The only difficulty here is just being careful with the arithmetic and careful with the negative signs. So in this case here, it's saying U2, which is minus 1, and V3 is 1, so that's going to give me minus 1 here, minus, and this is 3 times negative 3, so minus 1 minus 9, and if we work that out, it will end up giving us 8, and then we end up with 8, 16, and 16. Okay, so we're not quite finished once we've done that. That tells us that the Cartesian equation is in the form 8x plus 16y plus 16z equals some number, and we're not sure what number that is yet. But then when we look at this point here, 1, 2, 1, well, this point is on the plane, so therefore if we substitute this point into here, we're going to find out what that value for D is. So when x is 1, we've got y is 2, and we've got z equals 1. If we work all that out, we get 56. So therefore the equation of the Cartesian equation of the plane is 8x plus 16y plus 16z is 56. Or if I want to simplify that, and I basically just divide everything by 8, I can end up with 8 plus 2y plus 2z equals 7. Okay, so that's my simplified version. Okay, so there we go, the Cartesian equation of the plane. Okay, part C says, find the vector equation of the line that passes through D and is perpendicular to the plane, and then I want to find the distance from D to the plane. Well, if we remember from the previous part of the question, there we go, the point D is 5, 3, 7. So if I want an equation of the line that goes through D, well, it's going to go through this point here. So the point on the line I can write as 5, 3, 7 plus lambda lots of, and it's going to be 1, 2, 2. Okay, now the question is, why is it 1, 2, 2? Well, remember from that previous part of the question, we'd worked out what the normal to the plane is. So the normal to the plane, basically that is the cross product, isn't it? So the normal to the plane is the cross product, which is 8, 16, 16. Or, remember, I can simplify it down there as 1, 2, 2. Now, remember, the normal to the plane is basically this thing here. So, in effect, we've got the vector equation of the line from D that's perpendicular to the plane. Well, the perpendicular to the plane is the normal to the plane, and the cross product gives us the normal to the plane. So that's why we have the 1, 2, 2 there. So this is the vector equation of the line. that passes through D and is perpendicular to the plane. And then the second bit is what is the distance from D to the plane? Okay, now the way to do this is to say, well, remember the equation of the plane as before was, if we go back again, x plus 2y plus 2z equals 7. So we've got x plus 2y plus 2z equals to 7. And I substitute this in. So this is saying 5 plus lambda, that's my x value. So I'll put that in there. So 5 plus lambda is my x. And I've got 2, my y value is 3 plus 2y, that's my y value. And then I've got 2, 7 plus 2 lambda, that's my z value, and that is equal to 7. Okay, and if I solve that, I end up with lambda equals -2. Okay, so now that I know that lambda is -2, the next thing that I need to do is basically work out where this line actually intersects with the plane here. Okay, so if I put lambda equals -2 straight into this expression here, that will give me this thing here. So 537 plus -2 times 122. And if I do that, I'll end up with 3 minus 1, 3. Now that is the point here where the line actually intersects with the plane. So now I've actually got the 2 points here. So I've got the point D and I've got the new point of intersection. And I've got to find basically the distance between those 2 points. Okay, all I need to do to find the distance between those 2 points is if I do 5, 3, 7, so that's point D, take away the point of intersection, which is 3 minus 1, 3, that gives me 2, 4, 4. So that is basically the vector that represents how to get from those 2 points there, from D and the point of intersection. And now that I've got that, all I need to do is find the distance that is represented by that, and I can do that just by doing the square root of 2 squared plus 4 squared plus 4 squared, which is equal to 6. And 6, therefore, is what I was looking to find out, which is the distance between D and the plane.